Hello students, once again welcome to the LJ Institute of Engineering and Technology. Let's start with the course Mathematics 1, same chapter, indeterminate form, but topic are infinity minus infinity form, 1 raised to infinity, infinity raised to 0 and 0 raised to 0 forms. These are the last final forms and final topic of this chapter. So let's start with the form infinity minus infinity. First, we will see the working rule to evaluate this form. In this form, if limit x tends to a, f of x is equal to infinity, and limit x tends to a, g of x is equal to infinity, it is given, then the form of the limit x tends to a, f of x minus g of x is called indeterminate form of the type infinity minus infinity. That means if you put the value of f of x and g of x, this limit becomes infinity minus infinity. And for that, you have to compulsory take LCM. For this form, you have to keep this thing in your mind that you have to take LCM. So this form becomes 0 by 0, and after becoming this form 0 by 0, you can apply L'Hopital's rule and evaluate this kind of limit. So for that, you have to keep in your mind that in this form infinity minus infinity, you have to compulsory take LCM. How and when we will take this LCM? Let's have a look on the examples. First example, limit x tends to a into the bracket 1 upon log x minus x upon x minus 1. Let's have a solution. Let first take limit, and if we put first of all we have to always put the limit and we have to check which form it is. Then we will apply according that form a different logic. So if we put x is equal to 1, so we have log 1 is 0 and 1 by 0 is infinity, minus if we put x equal to 1 over here, the 1 upon 1 minus 1, 1 upon 0, that means 1 upon 0 is infinity. So this limit is of the form infinity minus infinity. Now as I told, if infinity minus infinity form occurs, you have to take LCM compulsory. So if we take LCM, so this x minus 1 goes to this 1, multiply with 1, and log x we multiply with the x, and in denominator multiplication of these two terms. So we have this kind of form, and this is always 0 by 0 form. You can check it. Okay, 1 minus 1 is 0, 1 into log 1 is 0, so 0, and in the same way denominator. Now after getting this 0 by 0 form, we know that we have to apply L'Hopital's rule. Okay, so by applying L'Hopital's rule, we have differentiation of numerator and denominator separately. So we have this differentiation of x is 1 and differentiation of 1 is 0, so 1 minus 0 is 1 only, minus into the bracket differentiation of x into log x, that means product rule, x into 1 by x plus log x into 1, and in the denominator again we have the product rule. Now after simplifying this, we have the x cancel out, and opening this bracket 1 minus 1 is 0, so we have minus log x in numerator and the denominator as it is. If we put x is equal to 1, we have 0 by 0 form. Before applying L'Hopital rule, let's just take LCM in the denominator only. So this x multiply with log x and goes to the numerator. So we have this, and this is 0 by 0 form again. So by applying L'Hopital rule, if we apply L'Hopital rule, then we have to differentiate numerator and denominator separately. So in numerator apply product rule, in denominator also here we apply product rule and differentiation of x minus 1. So we have this is the derivative. Now if we put 1 here, the log 1 is 0 and minus 1 as it is. Same way log 1 is 0 in denominator and plus 1 as it is. So we have minus 1 by 2, which is our final answer. So here you see that whenever infinity minus infinity form occurs, you have to apply that. First you have to take LCM, then start with the same process as 0 by 0. Now let's have a look on the second example. Evaluate limit x tends to 0, 1 upon x square minus 1 upon sec square x. Let's have a solution. First let capital L is equal to, L is equal to, we can take capital or small, it doesn't matter. Limit x tends to 0, bracket limit as it is. If you put x is equal to 0, so 1 by 0 is infinitive, 1 upon sine 0 is 0, and 1 by 0 is infinitive. So we have the infinitive minus infinitive form. So first what we will take? LCM. Yes, there you are. Now by taking LCM, sine square goes to this one and x square goes to this one, and in denominator just multiplication, so we have this form, and this is 0 by 0 form always. Before applying Aristotle rule, here you can see in the denominator, if we multiply and divide with x square, we have the standard limit, so we will multiply and divide this term with x square. So we have this form occurs x in x square x is to 4, and this x square into sine square x become 1. Okay, so we have a remaining part, limit x tends to 0, sine square x minus x square upon x is to 4, which is 0 by 0 form. And now by applying L'Hopital rule, carry on with the same flow as we have seen in previous lectures. Differentiation of sine square, differentiation of x square, differentiation of x is to 4. Then by simplifying we have this form. If we put x is equal to 0, we have 0 by 0 form. Again apply L'Hopital rule, we have this. If we apply limit, we have 0 by 0 form. Again apply L'Hopital rule, we have this. Again if we put x is equal to 0, we have 0 by 0 form. Again apply L'Hopital rule, we have this. And if we put x equal to 0, then finally we have answer minus 8 by 24. By cancel out, we have answer minus 1 by 3. So these are the example based on infinitive minus infinitive form. Now let's have a look on the last form, fifth form, 1 raised to infinity, infinity raised to 0, and 0 raised to 0 form. So first, as usual, we will start with the working rule to evaluate this form. Okay, so let's have a look on this form. This is most important. Okay, so to evaluate the limit of the form, this of the type limit x tends to a, f of x raised to g of x. That means for this form, question will be of the form this power function raised to function. That means base also function and power is also function. Now which takes any one of the form 1 raised to infinity, infinity raised to 0, and 0 raised to 0 for f of x greater than 0. Okay, now we proceed as follow to how to evaluate this kind of function, its limit by using this form. So as usual, let L is equal to limit x tends to a, f of x raised to g of x, where we know that f of x is always greater than 0. Now whenever this kind of form, this kind of type occurs, that function raised to function, always take log on the both side. So we have log L is equal to log of this limit. We can take log inside the limit, so we have this form, and we know the rule of logarithm, that we can take power this g of x forward, and we have this. So this form by default becomes 0 into infinity form. That means infinity into 0 form, we can say either of this. Okay, and we know how to solve this right hand side, that means 0 into infinity form. So by follow the rule as per 0 into infinity form on the right hand side, let us assume that right hand side gives the answer k. So we have log L is equal to k. After getting this answer, taking anti-log on the both sides. So capital L is equal to e raised to k, which is our final answer. So this is the process to solve this form, that 1 raised to infinity, infinity raised to 0 and 0 raised to 0. So let's have a look on the example so that you can understand better. First example, prove that limit x tends to 0 into bracket a raised to x plus b raised to x plus c raised to x divided by 3 whole raised to 1 upon 3x is equal to a into b into c whole raised to 1 by 9. This is most important example. Okay, so take a look on this very concentratedly. Let's have a solution. First, let's start with the left hand side limit. L is equal to x tends to 0 and this. And now by putting x is equal to 0, a raised to 0 is 1, b raised to 0 is 1, c raised to 0 is 1, 1 plus 1 plus 1, 3 by 3 is 1. So base becomes 1. And if you put 0 in the power, so 1 by 0 is infinity. So we have 1 raised to infinity form. So first of all, we have to decide which form is given. Now, as I told, if we have 1 raised to infinity form, then we will take log on the both side. So take log on the both side. Then after taking log on the both side, take log into the limit. If we take log into the limit, we know the rule of log, that power comes to the forward, and this form becomes infinitive into 0 forms. How? That if we put x is equal to 0 here, is this term into this term. That means 1 by 0 infinitive, and we know that this is 3 by 3 is 1 and log 1 is 0. Now, after getting this form, we know that either of these two functions have to take to the denominator. So this infinitive into 0 form becomes either 0 upon 0 form or infinitive upon infinitive. But here we taken this 3x to the denominator, so we have 0 by 0 form. After getting 0 by 0 form, we know that by L'Hopital rule we have to differentiate numerator and denominator separately. So differentiation of log 1 upon, that means it is reciprocal, and differentiation of this bracket a raised to x is a raised to x into log a plus b raised to x into log b plus c raised to x into log c divided by 3, constant as it is. And in denominator, differentiation of 3x is 3. Now 3 cancel out, and by simplifying we have this form by putting x is equal to 0. So a raised to 0, b raised to 0, c raised to 0 is 1 plus 1 plus 1, 3. So we have 3 in denominator, 3 3s are 9, and we know the rule of log a plus log b plus log c is log a b c, and we have 3 3s are 9, so 1 by 9. Now one more rule of logarithm, we can take 1 by 9 to the power, and by taking antilog on both sides, this log is cancelled out, so L is equal to ABC whole raised to 1 by 9, which is our final answer. This is the process as I told in working rule. So you have to just follow that rule only. Okay. Now one more example, you will understand better. Let's have a solution. Let L is equal to this limit as it is. Now first of all check which form it is. So if we put 0, so 1 by 0 is infinitive and tan 0 is 0. So this is the infinitive raised to 0 form. After getting form, just take logarithm on both sides. Log, you can see that we just directly take log inside. Rule of logarithm, tan comes forward. We have 0 into infinity form. If we get 0 into infinity form, then we will convert this to either 0 by 0 or infinity by infinity by taking any of these two to the denominator. So we have we will take tan x to the denominator. So tan x become cot x, and we know that log of 1 by x is minus log x. How? So log 1 minus log x, log 1 0, so minus log x. So we have this, and this is infinity by infinity form. So by applying L'Hopital rule, differentiate numerator and denominator separately. So differentiation of log x is 1 by x minus as it is, and differentiation of cot x is minus cos x square x. Before applying limit, just simplify. So x, we will take x to the denominator and cos x square x is minus 1 by sin square x. So minus minus cancel out and sin square x by x. If we put before putting x is equal to 0, multiply by x and divide by x. So we have standard limit. So remaining is x, limit x tends to 0, and x, limit x tends to 0 into x. So this is 1 and this is x. So this is 0. So we have final log L is equal to 1 into 0, that means 0. After getting this answer, compulsory we have to take logarithm anti-log on both sides. So we have L is equal to e raised to 0, and which is 1. This is 1 is the final answer. Same way, one more example of we have taken 1 raised to infinitives example, infinity raised to zeros example. Now 0 raised to 0 example. So let's look at the example. L is equal to this limit. If we put x is equal to 1, so 1 minus 1 is 0. In power, if we put x equal to 1, 1 minus 1 is 0. 0 log 0 infinite, and 1 by infinite is 0. So we have 0 raised to 0 form. By taking logarithm on both sides, we have this form. Power to the forward, we have this form. This becomes 0 into infinitive form. And rewrite this form becomes infinity by infinitive form. By applying L'Hopital's rule, differentiate numerator and denominator separately. We have this differentiation of log of 1 minus x square is 1 upon 1 minus x square, and differentiation of 1 minus x square is minus 2x. And same way in denominator, by simplifying we have this, and by putting this we have by simplifying we can cancel out this 1 minus x, and we have remaining part is this. If we put x is equal to 1, so we have 2 by 2, which is 1, and at last we have to take anti-log on both sides. So capital L is equal to e raised to 1, which is our final answer. Okay, now same as you have this practice example, that means DIY, do it yourself. If you practice more and more example, you will see how this happened and how you can solve it easily. Okay, so this is our final last lecture of this chapter. We will see you soon in next chapter. Thank you for watching. Keep practicing. Thank you.